Next in the series, INDU Talks. This one looking at lean manufacturing. And we'd like to begin by acknowledging that Concordia University is located on unceded Indigenous lands here in Tiohtià:ke, Montreal. We respect the continued connections with the past, present, and future, and our ongoing relationships with Indigenous and other peoples within the Montreal community. Here at Aerospace, we work with our university community to help mobilize knowledge. We co-create daily activities, questions, projects in development all across the university. We're running today's event also as a live stream to both YouTube and Zoom. Those of you joining us there, if you have any comments or questions, just pop those into the chat. We can do our best to read those out at the end during the Q&A. And the same for you here in the space. If you have any comments, questions later on, just raise your hand. We'll bring a microphone around to you. Okay. Now, very much my pleasure to introduce our guests and to give us more of a context for what's happening today. I'm happy to pass the microphone over to the VP for podcast for the Concordia chapter of the Institute of Industrial and Systems Engineering, and our host for INDU Talks, Andrew Sahyouni. Andrew, over to you.
Thank you, Aerospace. And hello, everyone. My name is Andrew, VP of podcast. Welcome back to another year. So today, I'll be your host, and this episode we'll be talking into a topic that's a core of industrial engineering, which is lean manufacturing. We'll explore what lean really means, how it's used in real-world industries, and how students can build careers within that field. So joining us today is a special guest. He is from Concordia's Department of Mechanical, Industrial, and Aerospace Engineering. He teaches courses like inventory control, production systems, and decision models. And his research focuses on lean manufacturing, supply chains, resilient manufacturing systems, and many more. Professor Onur, thank you for being here with us today.
Thank you, Andrew, for inviting me. I think you're doing a great job as a student society to have these talk sessions to promote industrial engineering and inform the greater audience about what industrial engineering is and what are the different aspects related to industrial engineering. So thank you again for inviting me.
Thank you, sir. I hope we're doing a great job.
All right.
So starting off in the beginning, so how would you explain lean manufacturing to a fellow industrial engineering student who has never heard of it before?
Yeah, so that's a good question. So, I mean, the concept of lean has originated from Toyota and from automotive manufacturing, but it's really a way of lifestyle, basically. So you first of all learn how to look at different systems to see what are the unnecessary things that are being performed in a given task, and how would you eliminate it so that you bring the essence of the activities. So in a company, in a production setting, or in a hospital, or in a bank, there are many activities that are being done, right? So these are designed based on a certain conditions to satisfy the customers. But sometimes companies do some activities because it is more convenient to them to operate like this. But that doesn't necessarily bring value to customer point of view, because the customer is looking for a certain product that has good quality and at lowest cost possible, and doesn't have to wait long time to receive that item. So, but because manufacturing requires running in the same product for a long time, so that creates a big waiting for production operations. So, so then what we are doing as engineers in Lean is to eliminate all the sources of activities that do not add value to the product. So anything that is unnecessary moving from point A to B without changing the product is a certain waste. And I don't want to go through the technical details of different types of waste, but anything that is not necessary should be eliminated. And what we are learning in Lean manufacturing or Lean principle is how to really observe the system, how to look at the system from a flow perspective, from activity perspective, to identify what is really unnecessary and how we can eliminate these inefficient activities. You can apply that to your day-to-day life, even your study desk or your room, to be cleanliness and orderliness, so that in the morning when you wake up to pack and go to class, You don't need to search for every single item in your room if it's unorganized. You waste time there to get to the bus, for example, and then you end up missing the bus. So how will you create cleanliness and orderliness so that you don't waste time searching for things, for example? So that's very basic, simple example of eliminating waste by being orderliness. And then, in a manufacturing or supply chain settings, you have many more different aspects that creates these, let's say, inefficiencies. And what we really teach students and learn in Lean is how would you analyze the system in a general way, in a flow perspective, to see what is unnecessary and how we eliminate this to make it more efficient, basically.
That is very interesting to hear. I also, even when I learned lean manufacturing, I thought of lean in many other ways, like as you mentioned, when cleaning my room or even going to school. Like it just teaches you in a way how to be time efficient and also minimizing as much resources as possible, only using what is needed.
Exactly. So you're eliminating the waste so that you're using resources efficiently. So in a production or supply chain setting, you're trying to reduce the costs of building things and in a timely manner by eliminating all these sources of waste. And that's how you become profitable or efficient to address the customer's needs. So in a nutshell, that's what we are trying to do. So we are teaching how to really observe the system, how to really find the essence of the activities to make sure that we are able to detect these inefficiencies, and then we equip students to deal with how to get rid of these inefficiencies, right? So all the other courses that we see, like simulation, optimization, and scheduling activities are there for us to then come up with some, tools to come up with a better solution once we identify the inefficiencies.
Great, that's perfect to hear. So moving on to our second question. What do you think makes lean manufacturing such a core part of industrial engineering compared to other disciplines?
Okay, so you see, industrial engineering has its own specific, let's say, task or duties or objectives, and an industrial engineer is a generalist. Okay, whereas when you look at mechanical engineers, electrical engineers, or civil engineers, they are more involved with specific product design, where they need to come up with better design of equipment, machines to run more efficiently. But without looking at the overall system perspective, you cannot make an organization run efficiently. So that industrial engineers are there to look at the system as a whole, and Lean is a perfect tool, let's say, set of principles to learn how to observe and analyze the system as a whole. So that's what makes Lean complementing the industrial engineering profession. And that's really what teaches you how to be an industrial engineer. Because if you forget the optimization, complicated formulas and tools, if you really know how to understand the problem, identify the inefficiencies, and come up with some recommendations based on principles that we cover in Lean, that would already provide improvements to facilities without even looking at optimization models, right? That's where we learn.
Yeah.
So a mechanical engineer might find the best machining activity that will make the grinding operation in 1 second instead of, let's say, 30 seconds. So that's a great reduction in, let's say, 29 seconds. But if in the next process, the next machine is waiting for it to be set up and it creates a huge accumulation of inventories next to it, then that improvement of that process serves nothing to the company. So that's why it is also important to look at the system as a whole. And that's why we are here as industrial engineers, to observe the system and identify inefficiencies. So that could be also in a hospital setting where the patients are being treated for, let's say, outpatient setting in a clinic or in a hospital. right? We need to look at how long a patient waits for it to be operated. And then we look at different, let's say, sources and activities to see where the bottlenecks are, where the, let's say, pain points are, and then we come up with some recommendations. So, and ultimately, again, as I refer to different tools that we are using, right? So optimization modeling, for example, or using many different scheduling tools. So those tools and optimization models find the best solution for a given set of situation of a company, right? So under my current situation, what is the best scheduling I can do? So that's the optimization does. What Lean trying to do is, okay, how we can improve the conditions so that we can go to a better operating condition. So we are trying to improve the states by better observing and analyzing the system, and that's what makes a perfect match of an idea of Lean with industrial engineering profession.
Okay. That's very nice to hear. Because seeing, you know, in industrial engineering where we're grasping Lean, simulation, OR, you can really see how everything blends in together, and almost everything like makes sense because you're understanding about, you know, lead times, bottlenecks, and for example, like the hospital scheduling, where we even did one in, as an example in simulation, you kind of understand how also that applies to Lean. So it's really nice to see how we're learning all these stuff.
Exactly. So what we are complementing Lean essentially is through those tools like statistical quality control, reliability, simulation, optimization, and production planning. Those are giving you the tool set to bring, let's say, a system to a better state through the improvement activities that we identify in Lean, basically.
Perfect. That's great to hear. So moving on to our third question.
Yeah.
It would be, so could you give us a real example, I believe it was mentioned, but something a bit more detail of Lean being used in the industry, maybe if it's in a factory, a supply chain, or something you've worked on your research?
Oh, yeah, there are, I mean, in today's world, there are tons of implementations of Lean, since Lean was, you know, is initially implemented in early 60s, 70s in Japan, and then moved on to the Western world through the MIT study and that was published with the book titled "The Machine That Changed the World," where they were explaining how, you know, Toyota is making the production work and how it compares to North American style of manufacturing. So after that, that then expanded to different sectors: healthcare, supply chain, finance, and all the other services where activities take place. I mean, so since we are closely related to manufacturing and healthcare field, I had many experiences with the aerospace industry, in which, you know, particular problems have been addressed with Lean, because you know, standard textbook Lean explanations always deals with, you know, high volume, repetitive type of manufacturing, whereas aerospace industry caters to more engineered to order, made to order products that are low volume but high variety. So then in that setting, how would you implement Lean becomes a bit more challenging, and let's say you need to adapt some of the principles to Lean differently, because as again, those standard principles should be transferred to these different settings. So recently, I've been working on a paint shop process for aircraft parts to see how the aircraft finishing should be completed to ensure that, let's say, the products are delivered on time to the customers. And the paint process is particularly challenging because that finishes affect the appeal of the product. as well as, let's say, the longevity of the aircraft itself. So it becomes a critical process, but it's a time-consuming process because of all the setups that needs to be done to paint the, let's say, different figures and scale differently on the plane. So the setup activities takes a lot of time. So in Lean, what we always cover is how would you reduce the setup activities so that you can change from one product to another quickly so that you eliminate the downtime associated with changeovers. So what we did was then looking at the different changeover activities to see what would be the better way to switch from one product to another so that it's easier to switch. For example, if a plane aircraft is going to be painted in blue, then a color similar to blue and a product that comes with a similar color should be scheduled next to that to make sure that changeover activities of the paint processes are reduced, for example. So that's one example in manufacturing. In health sector as well, right? So there are many, capstone studies that was done in the earlier years within the healthcare setting where students, I was involved in those projects, students looked at the admission process of the outpatient, let's say, clients, and they looked at the different scheduling and appointment scheduling methods by looking at from the product family perspective, because customers in that sense are the products or the flow that needs to be analyzed. So they had to look at the group of patients that require different types of treatment, and they come up with a different system of how to, let's say, combine the daily schedule of admissions so that at the end of the day, there is no overtime or there's no leftover patients. So all these lean principles can be applied in healthcare settings or in manufacturing settings in these examples. So on top of that, I see now in my academic search that the notion of Industry 4.0 with the Internet of Things and digitalization of operations, I see more synergy between Lean and Industry 4.0 as well, going hand in hand. So, on one hand, Industry 4.0 looks at more automation, self-decision making, but Lean is a complementary tool to Industry 4.0 because it helps to make the decisions in a decentralized manner. So, meaning that between the two processes, the activities can be done without a central authority making the decision. So those types of, let's say, recent trends I have observed in academia as well as in industry.
That's great to hear. I like the idea of the aerospace topic as well as the hospital scheduling. I believe also they do the same, how do you say it, like as we studied where we have a current state map, and I believe you have done the same process where you have a current state and you're changing it to a future state.
Yeah.
And maybe something they didn't hear about it, but I believe, you start basically with the processes, you check the changeover time, the cycle time, and all of these processes, and then you find a way in order to reduce that.
Yeah. So again, I'll go to my classes, our lean manufacturing classes, textbooks, but it starts with learning to see. The book's title is Learning to See because first we need to understand what is the current state, right? So we look at the current processes and observe the system and how it operates. And in learning to see, we are learning how to observe the system to identify those points where there are, let's say, inefficiencies. And then we come up with some future state ideal design that we need to get to, right? So then all the activities that we need to do to improve, right, is based on how do we reach to that future state that is ideal in terms of operation. So, and that also sets the pace for what we call continuous improvement. So lean is not something that we do once a year and then identify something and then we forget about it. But we have to continuously observe and analyze the system to make continuous improvements to improve the system year over year to reach to that ideal state. So sometimes students can think, okay, I can do lean analysis only once a year, and then what am I going to do with the rest of my time if I'm doing a lean manufacturing engineer, right? But that's not really, how the lean principles should be applied. That should be based on a certain continuous process to convince the employees in a company to commit to lean principles, lean idea, and then monitor the improvements regularly to ensure that the systems are evolving to a better operating conditions.
Amazing. That's good to hear. So finally, for our last question. So if students who are wishing to enter in lean or operation roles, so what are some ways that industrial engineering students can really thrive in lean manufacturing, both during their studies and later in the workforce?
Yeah, that's a good question. There are many opportunities for students to equip themselves with lean manufacturing skills. Obviously, first of all, they need to pay attention to the lectures and then understand the basic principles within the course. And then through internships and by being members, by having membership to industry organization like Institute of Industrial Systems Engineers or ASQ, the Quality Society of America, basically to get involved in the societies that practices the lean aspects, right? So that could be first way of, let's say, being exposed to lean, and then see what kind of, let's say, activities are being done in the industry to see the recent developments. Plus, obviously, problem analysis and solving analytical thinking develops by experience. So internships play a crucial role in developing those skills. So usually, larger corporations will always have some sort of continuous improvement, let's say, divisions, right? So the internships can be, let's say, arranged in those departments to see how the, experienced people in continuous improvement approach the problems and how they, let's say, integrate employees and bring all the organization together towards achieving this future state, let's say, or improvements. Because as an industrial engineer, you can come up with some ideal future state, but if you cannot convince the employees to commit to those changes, then it's hard to, let's say, achieve those improvements. So it's not only an engineering skill to, let's say, to come up with solutions, but it's also a lot of human interaction and communication with people is also crucial. So you need to be able to convince the employees, the staff, to adopt lean principles in their day-to-day operations. And that's where the social aspect of industrial engineering comes into play. So you need to be able to communicate properly and express your ideas clearly to the organization so that, let's say, everybody is on board with the improvements that you are bringing up. So all those skills, yes, we learn the fundamentals at school when we cover the courses and doing the projects. Capstone and internships play a big role in really getting your hands wet and then understanding how lean principles can be applied in practice.
Great, that's perfect. Also, just a very simple question. I heard that so in internships, that's the best experience you can get out of learning, like how to use Lean. If a person, also along capstone, if someone wishes to do a personal project, what is some field you would recommend for them to do on the side?
For personal projects?
Yes.
So, that comes to, again, being, let's say, in an internship setting where you are, doing the internship with an experienced continuous improvement manager might help a lot. All these concepts that we teach in the class will come to certain, let's say, understanding if you can link it to reality at some point. So in the courses, we give case studies, we explain through some examples, but sometimes it's best learning by doing things, right? So experiential learning becomes very important. And to achieve this experiential learning aspect, again, the capstone projects are ideal, let's say, mechanism to gain that experience. And I always recommend students to look at their capstone projects from the summer of their, let's say, fourth year, to ensure that they have a good contact and good project to complete during their capstone. So what I can say again is really the internships and capstone projects will help you more to solidify these conceptual, let's say, topics and understand the lean manufacturing so that you can apply and gain experience in implementation of those skills.
That's great to know, Professor Onur. Thank you so much.
No problem.
So that's all the time we have for today. I don't know if anyone has any questions. Yes, we have a question.
A couple questions here. I'll just pass the microphone. Also on Zoom, I know there's a couple people on Zoom. If they have questions, they could pop that into the chat.
Thank you so much, Professor. It was very interesting to hear what you had to say. I have a pretty simplistic question. If you could give one piece of advice to a student who's going on their first internship that hasn't necessarily taken Lean yet in school, what would you tell them? And they're going into a continuous improvement role.
So, since that student has never been exposed to, let's say, the Lean manufacturing course itself, but in our program we have the course such as Introduction to Industrial Engineering and and production engineering that helps understanding a bit how industrial engineering work and what is the let's say mindset of industrial engineers, right? So that should first of all help the student to in terms of setting his or her mindset in approaching the internship. The other thing, of course, is we as faculty members are here to help students in their journey to become industrial engineers. So our doors are always open to give advice, to give suggestions to students, so they can always come to us and we can give them some pointers to look. And it's always, engineering or even after graduating, it's a continuous learning process, right? So you never should stop learning by yourself. So that's something that you learn while you are being student also, is how do you learn how to learn things, right? So that, again, will be one of the tools. So you have to be open to listening and understanding the issues or the aspects in the internship. So for that student that is in his first internship who's never been exposed to Lean, should be eager to learn by himself or herself by asking us, faculty members, or looking at online sources to identify different aspects. And honestly, for that first experience is about more learning and being open to listening, because listening and observing and understanding is the first step in finding the solution. So if they just focus on that aspect alone, that would be a useful internship for that student.
Thank you so much.
No problem.
Hey, thank you, sir. Thank you, Andrew. Great questions. I'd like to ask, if lean manufacturing has so many benefits in manufacturing, how come not everyone does it? Why doesn't every factory that pumps out a lot of products try and implement lean manufacturing?
Well, most companies nowadays, one way or another, implement lean in terms of continuous improvement or quality initiatives. So it's unlikely to say that it is not implemented in other industries, but yes, maybe there could be a lack of visibility, right? And the other aspect is also the fact that implementing lean requires a lot of change of habits, doing things the old style or doing things the way people are used to in organizations, right? So to transform an organization to operate in lean mindset requires changing the point of view of employees. So that's why, we should not only learn how to implement lean skill set, right? Lean principles, but also learn how to convey the message to people in the organization so that we can convince them that is the right way or that is the more effective way of doing things, right? So that again comes to us industrial engineers to be able to convey this message to the organization so that it can be implemented. Because one of the things that has been observed in lean implementations is that at the beginning, everybody is on board, let's say, to do improvement, lean initiatives and improvements through lean principles. But after a few months, then people tend to go back to their old way of doing things. So that's why continuous improvement and changing the habits becomes crucial in successful implementation of lean principles.
Thank you. That answers my question very much. Thank you very much.
Any questions? No?
So I guess, yeah. So that's everything we have for today. Thank you so much for being here for this podcast. Don't forget, you can catch this episode on YouTube through IISE's channel or through the ForceSpace channel, as well as Spotify and Apple Music. And thank you so much, Professor Onur.
Thank you,
Andrew,
again for inviting me. And I wish you the best as a student society and yourself to be successful in your career and to organize these events even more frequently.
Thank you, Professor. Right. And thank you, everyone. And we will see you at the next podcast.
Thanks, Andrew. Thanks, everyone. Thanks for your questions. Thanks for coming in. Just want to let you know we're going to wrap up the Zoom and close up the live stream now, but this remains available on our YouTube channel, and you should revisit it. You should also, as Andrew just mentioned, follow along on Spotify, wherever you get your podcasts. Okay. Also, have a fantastic weekend.